All right, part 3 is here, and this is all about node deployment. So we are reading, like usually we do, from the installation step by step. And it seems that the node prereq script is also the one that can deploy the prerequisites for us. And to do so, we just need to find the node prereq script. We need to copy it to workers and NFS and master nodes and run it with some flags, for example, install packages or something like that. So let's give it a try. First of all, let's go out of Vertica and out of Postgres. So we have worker, master, and NFS. So this is the directory, CD item from foundation, and the node prereq. Where is this? This is the node prereq. So I guess we will start the node prereq with the master itself. So let's see what -t means. I have no idea. So let's run it as it is. Let's run and see what it says. -t, node type. Okay, so cool. So that's going to be -t. And we're going to say master. And what other flags are relevant here? etc hosts, using etc host parameters, set the system parameters. Okay. So let's run it on dry. Let's run it dry, and what it says that node prereq A, node prereq master all. Okay. Let's do all. Okay. There. Okay. So when you run it with all, it just makes sure that everything is there. So when you say all, it means that you are not excluding anything from the script. So basically, it would not do just the host or just the parameters. And I noticed that when we ran it, it already said that swap was already disabled. So this check was not necessarily unnecessary here. Okay, so there we go. We install stuff. Okay, cool. So now we are ready. Config file fs tab, no need to change. etc netlify, yes. System config host. Okay, it did quite a lot. So we're going to scp node prereq to worker. What did I do? No, a root to worker one root. Yes. And the password. Okay, and also let's move it to NFS. We'll see what it does for us there. Okay, let's move to worker. And there's the node prereq. So we're going to say node prereq -t worker, not worker, worker. And was it all? What was the command really? And what was the command that we ran here? --all. Okay, let's go for it. Okay, there are the packages. A lot of packages already installed, which is good. There we go, verifying. Okay, so, okay, that one is done. Let's do the NFS. Here's the file. There's the node prereq -t NFS -all. Let's see what it does. Okay, and okay, well, it did something, and ensured also the system parameters, net identifier. Oh, let's see what it does for us. Nano. Okay, so it seems that NFS doesn't require all of those things to be done. Master. Oh, okay. And here we have those 4 parameters set for us. And that's all it needs. And for older CentOS 8, that's exactly what we have. Okay, and system still be, and I think it already did it. It already applied those settings to all 3 nodes, but just to be sure, there we have it. Disable swap space, we did. Install prereq packages, that was already done. Default gateway settings, I think this one should be okay. Here's the worker. Default, yeah, default is great. Configure storage driver. Overlay, device mapper. So overlay, I think, is the default. Okay, so what do we do? It requires no extra configuration. Okay, so we don't need to do anything about this. Theme pool for Docker. Set up a theme. What? SDB. So this is how we set up. Okay, set up Docker, manage direct LVM. Create theme pools fast. You can use systems of more efficient. Block devices. You grow. Okay. I think we can skip this one. I never had a problem with the theme pool for Docker. I hope I would be able to ignore it later. Configure NFS. Okay, Linux NFS known issue. Workaround. This is what we need to run on the NFS to enable the workaround. Basically, your NFS gets stuck when there are too many read-write operations. So this is exactly what we're going to do here. We are going to enable the workaround. There we go. Volumes required, CDF requires item vol, DB vol, operation bridge requires 5 volumes. Okay, so here's the list. There's the CDF, and we need to set up the manage volumes. I think there is a script, a CDF script set up NFS SSH, and copy it to the NFS server. Okay, CDF script set up NFS. So we're going to master. And what was there? CDF scripts. CDF scripts. Okay, and we're going to do SCP, setup NFS. And then we're going to say root at NFS, root. Clone it there. Okay, we go to the NFS itself. Here is the setup NFS script. Okay, and we just need to run this thing. Okay, there it goes, and we need to add an enter so it would enable the last entry. Okay, there it goes. Creating the NFS servers as they are. Volume 5, volume 6. Now, it's not going to be using all of them because we're not going to use OBM. Okay, so it's explode. So now we will change mode for all of those. And we are not, okay. NFS uses Fort1. To check this on NFS server, okay, so we are going to modify NFS, so it's 4.2 and we need to change it. Okay, so we will nano the configuration file, and somewhere over here we need to say version 4.2 no. Okay, X and yes. Okay, and then systemctl restart NFS server. There we have it. Okay, limit access to the exported NFS directory. On NFS server, open the exports. Okay, I'm not going to limit access at all. Create logical persist now. Oh, okay. So synchronize HV3 power into CDF. Okay, this one is going to be interesting. So create local persistent volumes on worker nodes. So if you remember the previous installations, this is where we were creating some weird internal volumes that were supposed to serve as a COSO processing volumes or something. And we made sure that the server has enough disk space to accommodate the default values. Okay, and we configure NPV on each worker node, configure separated disk devices, configure for each APV or okay. So we're going to do this on the worker node. So those steps are specifically for worker nodes. Okay, we run the disks and we see that this has 219 gigabytes free. Okay, I think those need to be ran Okay, SDB. Okay, you can use COSO path to mount LPV systems and provide path during Helm install. See install storage provisioner topic. New unallocated. So we don't have unallocated, so we need to use you run the okay SDB, SDC, we don't have it. Mount T so I think second, let's read this file once more because in previous setups it had some specific mount grab disk. So we needed to create disks manually. And okay, classes on the master, Helm install, storage provisioner chart, kubectl get PV. So this is a little bit weird. So it kind of assumes that we have the hard drives added separately to the worker node, but this is not the case. Mount dev SDB and then TSDC. So I need to compare it to my previous setup, right? To previous steps that we used in the past. So for installing CDF steps, we'll go down to the worker nodes and okay, so this is the workaround, right? Mount disks, and when we read this thing, after mount disks, we need to use the steps that are similar in this one. So basically, we need to create three kind of disks on our worker node, which will be mounted as disks later. And previously, we used this by using dd command, which would create the disks for the required size. Then we would create the mount points for them. Then we make them into the volumes, and then we would mount them, right? And later we need to add the FS stub entries so they would appear on reboots. Now I'm looking for the same steps over here, and I think that I'm kind of missing the point that it just doesn't listen, doesn't list the things that I need, right? Main mount disks, and I don't see how separate disk devices. 3 additional disk drivers. So this section covers. Now let's read another section. Make dir, and in this section covers because we need to edit one additional separate disk on each worker node. Okay, and they would be new hard disks. Is there a variation? Oh, use existing disk devices. There we go. There we go. So this is what I was looking for. So we're using 16, 8, and 8. And I can actually use a bigger setup. What was the setup in the original procedure? The original procedure, it had, no, not this one. Sorry, it says 30, 100, 30, and 30. And SDE was 50. So 100, 30, and 30. That's what I need to do. And this is exactly what I'm going to do. I'm going to say 130 and 30 because I don't want them to suffocate. So it means that we need to change this procedure slightly. This one is going to be 100, 100 on the worker here. It's going to take a while. And then I'll run it twice for 30 gigabytes. Let's see how it plays out. There it goes. Go. Yeah, well, it's creating a 100 gigabyte big hard disk. So as you see, this procedure takes time, so it would make a lot of sense for me to actually clone this worker into a separate template later, where I could be just using it later to add nodes as I please, based on all of this preparation that we made. Okay, so there it goes. There it is done. So we'll just repeat the steps for volume 2 and volume 3. So that's going to be volume 2. Basically, it creates this file, and the file contains 30 gigabytes of empty space, but allocated just for this file, right? It's very similar to what we did with the swap file for vertical, where we just created a file that can be used by the suite or by vertica at the, for example, when it needs swap, but the file is not allocated to the specific disk location, like physical address space, or like a file in the file system that can be shuffled around. It's very important if you're using SSD storage. Here it's not the same importance, but still the same principle. Okay, and now we're going to do it for volume number 3. There it goes. So next step for us would be make a fast into a specific file system, right? So it's going to be ext4 file system inside those files, although the file system that hosts everything is actually, it's the ext. No, it's not the ext, it's the other one, the newer one, xfs, I think. But still, if it requires it to be ext4, we'll use ext4. Any second now. Any second now. There we go. So the first one is a make a fast ext4 out of the first volume. Let's see how long it takes for 100 gigabytes. Oh, that's it. It is done. Volume 2. Okay, and volume 3. Next step would be making directories to mount those files as hard drives. So this is 1, this is 2, and this is 3. And now we will mount volume 1 to LPV1. And then we'll mount volume 2 to LPV2. And then we'll mount it to LPV3. And the last thing is the FS tab, which would ensure that those volumes exist after we reboot the system. So it's going to be nano, FS tab, and now we need to add those 3 entries. All right, like this, and save. Run the following commands to change the ownership. So we'll change the ownership like this. And now we see that those are 19999. And now df-h. And df-h says that everything is exactly as we should have it. Okay, as you see, the resulting aspects is because when you later edit the sizes in values XML, you would get 15 for ledger and everything else, but we're going to edit actually to 100, to 99 and 29 and 29. Okay, fantastic. So this concludes the node preparation as far as I see it, right? And I'm going to say that this worker is going to be a candidate. So take snapshot. I'm going to say 3 racks plus disks, template candidate. Okay, so now I'll have template candidate for me and power it on. Let's read the next topic. So configure installed, config JSON, pre-check script, agent method, and install CDF. Okay, so the next part would be actually the CDF installation. So this is it for this video, and I'll see you in the next